Hello, everybody. My name's Jacob McSwain, sometimes called the Greater Ginger as compared to Aaron at work. So I'm going to be giving a talk today about HashiCorp Nomad, which is a container orchestration tool. A little bit about me first. I'm the DevOps engineer, well, no longer the DevOps engineer. We actually hired another one. But I'm a DevOps engineer at Clever. My kind of specialty is making monolithic applications a little more resilient, automating procedures, easing our workloads, the DevOps thing, and cloud stuff. You see my sites there at McSwain.dev. I'm very proud of the .dev domains. So a little bit of a HashiCorp. You've probably heard of them before. You've probably used them before, things like Packer, Vagrant, Terraform, Vault, Console, and of course Nomad today. Terraform being for provisioning infrastructure, Packer being the automated building of images, and Vagrant being managing virtual machines, Vault for secrets management, Console for service discovery, and Nomad for application orchestration and deployment. They're an open core business model, meaning their core code base is open source, and they have more proprietary features offered in their enterprise versions. And I discovered Nomad specifically because every time I had a problem with DevOps, had some kind of pitfall I fell into, HashiCorp almost always had a solution. So I couldn't figure out infrastructure as code. Of course, Terraform exists. And then later I was like, well, I'd like to have reproducible images everywhere. Oh, hey, Packer. Okay, well, what else do they have? And that's when I discovered all the rest of the services, and they've got a great ecosystem that all ties in great together. So what is Nomad? It's an application orchestration tool. It will run on any platform that Go can compile to. So, I think it goes so far as to ARM v6 and PowerPC, like basically anything with a CPU and some RAM you can run Nomad on. It can run Docker containers, native binaries, Java applications, and probably more. It's got a very extensible plugin interface. And I have a quote here that I thought was really good from Matthias Endler, who is an engineer at Trivago. He says, the best part about Nomad is it's easy to replace. There is little to no vendor lock-in because the functionality it provides can easily be integrated into any other system managed services. It just runs as a plain old single binary on every machine in your cluster. That's it. So if you're starting to get into container orchestration and maybe Kubernetes is a little too heavy for you, a little too advanced, complex in general, but Docker Swarm isn't quite what you need, Nomad might be a great middle ground, especially that you're not going to be tied to this one product. You can just replace it easily. And why Nomad versus something else? It is a single binary. I think it's like 75 megabytes. It's scalable. You can add clients and remove them on the fly. It will handle orchestration of them on its own. So for example, load starts getting real bad on your servers. You can use an auto-scaling group in AWS or equivalent and just start spinning up servers, and they will automatically join the cluster. And then when they go to bring themselves down, they will go and deregister cleanly, and you won't have to worry about containers getting missing or anything else. It's region, a data center, so you can run Nomad in multiple regions, multiple availability zones, totally different cloud providers if you want to, and they will all talk to each other nicely. They have job files, so Kubernetes, of course, has that as well, that define the resources it uses, the environment variables, and so on, so you can keep your deployments in your VCS system. And then it also has Vault and Console integration and probably more services, but those are the main ones. So service discovery and secrets management handled right there at the orchestration layer. And it's very pretty. It's got a very modern interface, and this is all still in a single binary. You don't have to run a whole web server, reverse proxy, stuff like that. It handles that for you. And you can see there, that's one of our production environments that's running, 6 services. And in there, you can see on the left bar, you've got jobs, clients, and servers. So servers in this case are usually your smaller servers that don't actually run the containers or whatever you're deploying. They manage the whole infrastructure or the whole environment as a unit. And then clients would be what the containers are actually run on that do the processing. You can see you can filter your jobs by type, status, data center, and so on, anything you need to narrow it down. And a slight summary showing that, hey, that email server has been deployed several times. Most of the deployments were failed. Newest one's always on the left, so that green there shows that the light green means it's running and everything's fine. Dark green means it's been completed successfully. Another screenshot here is of the details of a service. So you can see here that this is the front end service. You can see its active deployment was deployed properly, or actually this one was while I pushed a deployment to it, but it had not been applied yet. So you can either go in and have it automatically promote canary releases, do an A/B and stuff like that, or you can go in and manually update them. And so you can see that it had one canary placed, and that canary became healthy, so it's ready to promote. That's the orange button on the right side. And whenever you're ready to go, you just hit that, and it will automatically handle all the port mapping and everything else like that. And then this is the example of the client's page, which shows you a specific AWS instance, the resources that it's using, the what deployments and jobs are actually running on that machine. And so it's very informative, and its UI is really nice for at-a-glance information. And then so who uses Nomad? We do, obviously. Roblox does. Trivago, which that quote that I pulled about not having vendor lock-in is actually from that first site under Trivago, which is actually a really good article to read. I'd definitely recommend that. The maybe you don't need Kubernetes article. And then also another link from Trivago themselves talking about Nomad. Target uses it as well. Pandora, eBay, Jet.com, which if you haven't used is actually, I believe, a subsidiary of Walmart, and Circle CI all use Nomad for their production systems. We've been using Nomad ourselves for almost a year now, maybe 9 to 12 months, somewhere in that range. We've had little to no issues with it. Anything that we have an issue with, it's usually been user error, and well, it's always been user error. I've never had Nomad itself actually fail to do something or crash or have any kind of instability. And why not use Kubernetes over it? Well, Kubernetes is complex. There's obviously a use case for every application deployment system, because if there wasn't, we'd all be using the same thing. But Nomad versus Kubernetes, Nomad is very simple to set up and use. Running a development server to test things locally is as simple as one command. And when you're ready to kill it, you just hit Control-C and you're done. It's a single binary, so you don't need to go and make sure Docker is installed on all your hosts and turn on all the options, everything that Kubernetes needs to talk to each other. It can run more than just Docker containers. It's not locked into that. You can run native binaries. You can run Java applications, whatever you need on it. So legacy applications that you're having a lot of problems moving forward, this could potentially be a great solution for that. And it's a much simpler architecture. Kubernetes has several services, I think a half dozen services working together to provide the whole functionality of the platform, whereas Nomad's just one. And versus Docker Swarm, I don't know if anyone actually uses Docker Swarm in production. From what I've seen, a lot of people who use it end up moving to Kubernetes. There may be other container orchestration systems out there like ECS, but these seem to be the major ones that you run generically no matter what cloud provider or platform you're on. And so why wouldn't you use Nomad? The biggest con to Nomad that a lot of people have is that it doesn't do everything. It has no authentication layer. That port that it listens to for the web UI is open to all unless you set up some kind of configuration around it, verse proxy, whatever. There's no rights management. You can't tell which users have the ability to go and update certain deployments and things like that. There's no advanced networking policies. The networking is dead simple that you define a service in console and that's it. It doesn't do networking like that. And so things like that, it's trying to keep it simple while also providing exactly what you need to deploy applications. And so job files. So I mentioned earlier that those were the way to keep your deployments as code. They are HCL-based, HashiCorp configuration language, just like Terraform. So syntax will look a little familiar if you've seen that before. I kind of want to go over real quick what the job file looks like, because that's usually the simplest way to show what a provider can offer while still being able to explain it well. So this is actually a deconstructed job file that I've taken from one of our running systems and cleaned up a little bit, removed client names and so on. And it's running Postgres 11 Alpine in Docker. So you'll be able to see everything that we do for handling volumes, logging, and so on. And so it's dead simple. You define a job called Postgres. You can define what data centers to run it in. So that's an array. You can tell it, hey, we run ours in AWS, and we say for multi-regions, each region has its own data center name that matches that region. Whereas console, I know, uses DC1 by default. So you can specify that however you'd like. Type is service. So the service is for your actual services versus the complement of that is system, which would be internal systems to Nomad, things that I need to run on every single instance and so on. You have a job group called Postgres. You can set it to have an initial count of how many instances to run inside of that, or you can have it be implied and do auto-scaling if you need to. So in this case, this is a minor client, not much traffic, so its count is 1. There's only one Postgres running at a single time. And then in that, Postgres should restart twice before it decides to fail. Its interval should be 30 minutes before it's considered truly stable. It'll take 15 seconds to check if it's stable or not before it will determine whether it needs to restart it. And mode means that if it restarts those 2 times, it will be marked as a failed deployment. And it will roll back to the last known good deployment, which is a great feature of Nomad. You have your task inside of the job, which defines your driver's Docker, so it'll be a Docker image. Your config for that task, you have Postgres 11-Alpine for your deployed image. You find your port mapping there, so we have a port called DB that'll be 5432. Now on the host, when this is run, it's actually mapped to a randomized port. You don't have to know what port it's actually running on the host. It will handle that on its own. But if you do need to make it static, there's a configuration line a little bit later that will do that. The reason that I prefer doing randomized ports is for the ability to do A/B deployments, so you can have 2 instances of the same app running without having port conflicts. And in volumes, standard Docker volume, so we have a mount on all of our instances called Docker data, and in that we have whatever folder we need for each deployment, so Postgres folder, and that's of course mapped to the internal var lib Docker or PostgreSQL data, which is the database internally. Logging. So logging's very specific in this case because we're using AWS for this deployment. Our instance has a instance profile that allows it to write to AWS logs. So in this case, if you don't specify logging, it'll use an internal logging system, which if you click on a deployment and hit the tab that says logging, it'll show you just the output of it. It will disappear whenever you restart it or redeploy. So it's not great for production use, so that's why we pipe it to CloudWatch logs. And so you can see we specify the region, the group, and whether to create it if it doesn't exist or not. The template. So this one's really interesting. This is where the Vault integration comes into play. So we obviously don't want to put our database credentials in Git. So in this case, we have configured in the server config that where our Vault lives, credentials it needs to log into it, what policy to use, and so on. And so with this, with secret syntax, it will actually interpolate the values from Vault. So you can see that we have a secret called secret/prod Postgres with the data, username, and password inside of it, and we just interpolate those in environment variables there. The destination can technically be anything you need. It doesn't actually go inside the container. It stays on the host. It's got a good permission set, so not any user on that host can just go and output it and find out what passwords are. And then env means is that these environment variables. You can do this and have this file go inside the Docker container. So if you're templating out, like I know GCP, or I guess Firebase, has a service account.json file that you can't load by environment variables very well. If you needed to go and place that inside of the image, you could use this to template that out. And then you have an env stanza, which will set environment variables. PostgresDB, obviously, it tells you what database name it should create when it starts. That isn't in the Vault configuration because the database name is database. It's not sensitive information. But if you need to, you can always go and remove that from there and add it to your template line. And then the Vault stanza just says use the Nomad cluster policy, which there's good documentation on their site on how to set up the policy to allow Nomad to talk to Vault. And then change mode restart means that the container will restart should any of the used data points change. So if you go and have rotation set up and rotate credentials in Vault, it'll automatically restart the Postgres job to handle that. Of course, Postgres, if you already have data there and change those environment variables, it will not recreate the new user, password, anything else like that. So that's something to keep in mind. You still have to handle that and environment variables changing on persistent layers like that. And then resources. So you can define a CPU and memory cap for it. CPU caps aren't easily done. It will try to keep it below that, but obviously if you have some kind of spiked load, it may exceed that. The CPU value is in megahertz and memory values in megabytes. As you can see, this one's allowed to have 1 gigahertz of CPU, which I find is an odd metric for CPUs, but it is what it is. And then memory, of course, being a hard cap to 1 gig of memory. And then on the network, it will also use the database port and expose that to console and whatever it needs to be. Then you define a service. So this is actually we'll be talking to console. So you'll now have a Postgres console service inside of your console environment. If you choose to use that, you don't have to use console with these, but obviously if you're going to be going to HashiCorp system, HashiCorp ecosystem, it's not a bad idea to try and leverage the built-in solutions. So that tags property is actually very interesting because that's not for console. We have a load balancer called Fabio that runs inside of all of our instances. It is a reverse proxy that works really well with console. It's actually written for console. And it will go in, find any services you need, look at the tags on that services, and define routing for that. So we have an external load balancer like an ALB on Amazon that will talk to Fabio, which will use console to determine where everything's running. So in this case, port 5432, which is Postgres data port, will be listening on that port and for TCP. Of course, you also define that the service port is DB, like we defined earlier, and you have your health check in there. So we named it Postgres Alive. It'll check on that TCP port every 5 seconds, and it'll time out after 3 seconds. Part of that is restart as well, the same as we saw earlier. It'll check that 15 seconds after it starts up. It will be fully defined as healthy 30 minutes after it's deployed and has responded to health checks properly in that time. And that's most of everything you need to make a job file and do deployments and define your resources and everything. The biggest one is the update stanza, though. That's where I really fell in love with Nomad because you can do blue-green deployments, canary releases, A/B testing, and rolling releases. Basically, every major deployment strategy is supported out of the box. So in this case, I love doing blue-green. Clients love it when you tell them you have zero downtime deployments. So in this case, the update stanza says that the max number of parallel connections you want is 1. Of course, you configure this for higher availability deployments where maybe you've got 5 instances of the same thing running. Canaries, canary, telling it to run one canary, to run this container one time, don't try to horizontally scale it or anything, and use that to determine whether the code that's gotten deployed will work or not. And of course, that's when you do your health checks and so on. Your min healthy time, so that says that it has to be healthy for 10 seconds before it is determined to be healthy enough to promote to full deployment. Healthy deadline, if it's not healthy within 4 minutes, go ahead and mark it as failed. Progress deadline, may have gotten healthy and progress deadline mixed up. I actually don't know the difference off the top of my head. That's something to look into. Sorry about that. Auto revert true means that if the canary fails or if for some reason it goes, succeeds the health checks, it dies at some point later, it'll revert back down to the last known version. And I believe that's actually a default value for it because it's such a good idea, but I did that explicitly. I'd rather be explicit than implicit. Stagger 30 seconds. So if you're doing multiple releases, multiple canaries, maybe you don't want them all starting up at once, putting in immense load. You can stagger them to start 30 seconds after each other. And then the health check to use to check if the canary is healthy. And that was defined in the service stanza. So actually running Nomad. Now that we looked at the job file, the features it offers inside the job file, and hopefully that helps give you an understanding of what it offers, different configuration options and things like that, so you can understand the features. Running Nomad itself is dead simple. If you get the binary, it's I don't know if it's necessarily a static binary, but it's just a single binary you download, run it from anywhere. Nomad agent-dev, and you've got a development server running on your local machine. It listens on port 4646. I did in a cinema to help show what it looks like, but it's basically a large output. Let me undo screen mirroring here real quick. Okay, you should be able to see that. And so this is what the output looks like when you first run it. So you run nomad agent-dev. It'll start for a second, and then you'll see advertising addresses, bind addresses, and so on. And any output that you need for debugging is all right there. And it's done. That's all you need to start the development server. And it listens on port 4646. It does some internal communication called Raft, which determines like electing a leader and so on in a cluster. That's done on 4647. That's using RPC, if anyone's interested in that. That's all internal to Nomad, though. Move back to this. And so, yeah, it runs on port 4646. If you go to your browser and load that up, you'll see the same UI that I showed earlier. Or if you need to, it has its own API as well. Of course, the API is a little bit in flux. The majority of the API calls are stable, but they are adding constantly brand new APIs, anything you might want to do with the API. And so these might not be so stable. Obviously, look at the docs and give you the best bet for what you should use or not. And then running Postgres on this server. So you've started your server on your machine. Now it's time to actually run something on it. So I'm using a little weird syntax here for that command. I use fish as my shell. So there's no setting the variable explicitly before running a command. You have to do env first. But env nomad address, and you set localhost in this case, or if you deployed it somewhere out on the internet, say nomad.clever.com, you put that there. And nomad job run, and then the file that's on your local machine. It will take that file, parse it, send it up to the server, and the server will handle it as it needs to. and it runs, just as simple as that. Of course, if you do canary updates and so on, there might be a little more steps that need to be done. It will say good. That command will output finish, and then you'll need to go and either, if you had set it to automatically promote, it'll just do that. You don't have to worry about it. But if you need to manually do it, you can go to the web UI, or you can do Nomad job status on that. I believe that's it, or maybe Alex status. One of the two. Obviously, documentation will be your best bet here. But for the most part, just doing job run, it's done. There's nothing else you need to do. And another major thing I want to talk about is the pitfalls of it. So it is simple. It doesn't handle everything. It does container orchestration really well. It does interoperability with HashiCorp services really well. But there's a couple of pitfalls with it. You don't have an ACL for the UI. The enterprise version does. You do have an access control layer if you do let to go to the enterprise version. Or you can, of course, spin your own. And there's probably plugins out there that let you handle that while still maintaining the open source version of it. In our case, we do IP whitelisting. Only certain IPs of ours are able to access the web UI. And for the most part, we have a culture of trust at our job. And anyone who needs to promote or deploy to a deployment has the personal responsibility. They are allowed to. They know the code they've written that they're deploying. That's a major part of that. Storage persistence. By default, if you run it on one server, that storage will always be there. But there's a huge problem you run into when maybe you run 3 clients out there. And Mongo, for example, or any database could run on one specific server, but you don't know which one because there's no need to. It needs to handle, the orchestration handles that. So should it go and mount a new disk every time it goes and deploys that? Should there be a shared mounted disk, like an NFS share, across all 3 or all instances of the container? It really depends. That's really a solution that's left up to the user. In our case, we actually took Amazon's EFS, which is their elastic file system. It doesn't work for all things. Some databases really don't like NFS. It's not quite fast enough in some cases. But for a generic purpose, persistent disk across all your instances, we just have that as the NFS share. We only run one instance of Postgres and so on, so we don't have sharding or anything else like that we have to worry about. Should there be a second one up, it will look at that file, see that there's a lock from an existing Postgres that is running, and obviously exit. Storage persistence is interesting. There's many solutions out there. It really depends on what's best for you and your company and for your deployment. Logging is another pitfall. Like I said, the existing logging driver that's default will just log it to the web UI. It won't persist after you redeploy or restart a service, or if it fails, you can't even look at the logs. So there's a huge problem with that. Again, that's mostly there just to verify that it's ran, and actually doing proper logging is left up as an exercise to the user. It makes it very simple. I know we use AWS logs. It will use anything. If you run Docker, it will use any Docker logs you can use. So you can pipe with Gray logs by default. If you're using Docker, AWS logs, I believe, is actually a Docker default as well. But you know your own logging stack. You know what you need to do for that. It's one of those things that's not going to stand in your way, but it's also not going to do it for you. And then networking. There is no networking by default. It creates a random port unless you specify otherwise to use a static port. Console will grab everything you need to be able to orchestrate based on console. If you use console, you know what to do there. And that's the same case. It won't do it for you, but it will try to make it easy for you to allow what you need to do. And then where to go from here. So you've learned about Nomad and so on, but how do you actually use it in a production environment? So as it turns out, if you're familiar with Terraform, there's a very great resource on their GitHub that allows you to, it's a Terraform module to run Nomad in a production-like environment in all 3 of the major cloud ecosystems. So we use AWS ourselves. We have made a fork of Terraform AWS Nomad, that repo, and added business-specific tags and so on, and things that we need for our deployments. And we now have a base repo that we can use to deploy Nomad on AWS. Google and Azure also have this as well. The way that one works is interesting because it uses the resources it has available to orchestrate joining a cluster. So for AWS, it will tag every resource with a certain unique identifier that's shared between that deployment. So if you use an autoscaling group and bring it up, when it boots up, it will look at the tags of its peers and determine which cluster it should join, if any. So it really depends on the cloud provider as well. And you can also do an on-premise install too. There's nothing stopping you from just downloading the images, running them, adding the configs, just like that. So hope that was helpful. Are there any questions anybody would like to ask? Yes. Oh, that's new.
So in the job file you showed, there was one image, and I was wondering if there's any support or if it's within scope to have the equivalent of your Docker Compose or Docker Stacks.
Not quite sure what you're asking, sir. So if I understand correctly, the job file, I'm sorry, can you repeat it? I'm not quite sure what you're meaning.
So if you have multiple images that need to speak to each other, but not necessarily communicate outside of that group of images or group of containers, then that's the functionality you get with Docker Compose or Docker Stacks. And I was wondering how that fits into Nomad with job files.
Right, so that's actually a great example of Postgres. So Postgres shouldn't be deployed outside of, or it shouldn't be publicly accessible for most cases. In that case, we actually have on Fabio or whatever load balancer we have, we just don't expose that. By default, nothing is exposed unless you've set it out on the instance. Inter-process communication uses console, so if you need your application to talk to Postgres or so on, you'd hit the console API or whatever you need to, use its DNS system to talk to that. Is that kind of what you're meaning? Okay. Anybody else? All right, well, thank you so much for having me.